Today we're going to be talking about multiplying radicals together. We're going to include things both inside and outside of radicals to see how they work together. We are, however, going to be dealing with radicals that have the same index. So if you think about the cube roots and fourth roots, in case of this guy, we have that square root right there. That's the index of the square root, or I'm sorry, of the radical. We are going to stick with the same things with each of our problems. We're not going to mix square roots and cube roots together today. But as long as we're dealing with radicals, we have a couple of options to simplify them together. I listed as two separate options. In all honesty, I kind of view them as very much the same option, but let's take a look at them. Option one, simplify what you have before you do anything else. Okay, then start multiplying. You multiply your outside values together, and you multiply your inside values together. Okay, don't mix the two of those. And then once you're done with that, then go back and simplify things again. Option number two. Option number two gets right to business. Start multiplying things together. Multiply everything that's outside of a square root or a cube root or a radical together, and then multiply all the things that are inside of the radicals together, and then go on and simplify. What are the advantages and what are the disadvantages? And if we look at option number one, obviously we've got more steps. They're not big steps, but they're more steps. The downside is we have more steps. The nice side is if we simplify things first, we are going to be dealing with smaller numbers inside of our radicals. If we simplify things again at the end, because through that multiplication, maybe some more simplifications may have been found, we're simplifying more often, but it's smaller pieces both times. Option number two, clearly only two steps. However, when we multiply, if we're creating bigger roots of things that we need to simplify, our simplification step may be more involved. What I find is with practice, you're going to find yourself using probably both of these options. As a matter of fact, with practice, you'll probably decide that they're not really different. They're really the same thing. But I find that sometimes students get too caught in what they need to do. They need a list to go with. So here are our two options of our lists. Whichever one is going to work better for you, go with that. With a bunch of practice, you're going to find yourself doing different things in different circumstances. In option one, we're going to start by simplifying. You'll notice in this step, I took the 125. I figured that was a 25 times a 5. Took the 5 out as a perfect square from the 25. The x squared was the x cubed was both an x squared and an x. The x squared was able to come out, and that's how we are going to be left with a 15x times the square root of 10x squared when we go through our second step of multiplying. However, we still need to do a little simplification. So we're going to take our 15x, we're going to multiply it by another x as that x squared now gets to come out, and our final answer is going to be a 15x squared, square roots of 10. If we take a look at our second option for doing this, it's not going to look all that different. We're going to multiply these guys together first. We'll get a 250x to the fourth. And we will then begin to simplify. We'll take that 250, we'll make it into a 25 times a 10. We'll take our 25, we'll bring out that as a 5. We'll take our x to the fourth, we'll bring that out as an x squared, and leave that root of 10 behind. Putting those putting those coefficients together, we get a 15x squared, square root of 10. Not a different answer, shouldn't be, not too surprised. Let's take a look at this one with option one. Option one, I'm going to take 4 times the cube root of 216x cubed, and then we're going to make that into a 2x squared y beyond that, all underneath the square root. The second part of this is going to become a 5 times a cube root of let's put the y cubed up here, and then let's multiply by the 2, the x, and the y. Now we're ready to take some cube roots. Cube root of 216 is 6. We have the x as well. We're left with a cube root of a 2x squared y times a 5y cube root of 2xy. And we're now ready to do our multiplication. We'll multiply all the things on the outside together. The 4, the 6, and the 5 are going to become a 120 times an x times a y. And then we'll be left with a cube root of a 4x cubed y squared. Last but certainly not least, that x cubed wants to come out. It is a perfect cube, so we have our 120xy times that x that we're going to bring out. That'll leave with a cube root of 4y squared, and we'll simplify that down to 120x squared y cube root of 4y squared. As we look at this by multiplying first, we're going to simply multiply our 4 and our 5 together to get our 20. And then we're going to take a look at our cube root of 532 times 2 is 1064. And we'll have an x to the 6th and a y to the 5th. Now, as you can see, doing it this way, we get some larger numbers sometimes. And perhaps looking back at where those numbers came from, we might be able to see how we want to break them up. I know that 216 is a perfect cube. It's a 6 cubed. I see the x to the 6th now already together and a y cubed. We're still going to be left with a 4 and a y squared. From there, we're ready to take our cube roots. We'll take our 20. We'll multiply that by a 6x squared y and the cube root of 4y squared, leaving us with 120 x squared y cube root of 4y squared. As I mentioned, although I listed these as two separate options, I really believe they're very much the same. They accomplish the same task. I'm still looking at the values of the numbers as I'm doing things. The question is, do I want to put everything together before I start simplifying, or do some simplification along the way? The more practice you get, the more you'll see what you want to do and when you want to do it. We have one last example here today, and that has to do with multiplying, but then adding and subtracting as well. If we look at this, it's a FOIL situation. We're going to take our 3 and we're going to multiply it by our 4. We're going to take our 3 and we're going to multiply it by our square root of 3. We're going to take our square root of 2 and multiply it by our 4. I'm going to turn those around so that they're written a little bit more conventionally. And we're going to take our square root of 2 and we're going to multiply it by our square root of 3. Now, from there, we're simply going to simplify each term and see what is left. We have a 12, we have a 3 square root of 3, we have a 4 square root of 2, and we have a square root of 6. Now, in this example, nothing else is going to simplify. This is our final result. At this point in time, though, we kind of go away from our multiplication rules that we're talking about in this video and into our addition and subtraction rules that we have looked at earlier. Okay, we would want to make sure that all of our radicals are simplified. We'd want to make sure that if we did have any that were like terms, we would put them together. I hope this helps in your understanding of multiplying radicals together. And if you have any questions, don't be afraid to ask.